Okay, here we go. Good evening, everyone. This is the second session in the series of webinars that Ethereum Greece has prepared for you, in which we are inviting top researchers and engineers that are actively building and working on Web3. Today with us, we have Derek Lee, Senior Product Manager at Core Protocol at Offchain Labs, the team behind Arbitrum. So Derek, the stage is yours.
Awesome. Hey, I'm going to share some slides. Great to meet you all. 1 second. Awesome. So feel free to interrupt me during this presentation as well for questions. Today, I'm just going to briefly go over what Arbitrum is, and then go through one of the projects that we've been working on for quite some time on our engineering team. Can everyone see my screen and everything looks good? I'm going to assume
everything works. Everything works.
Awesome. Okay, sweet. Cool. So brief introduction to Offchain Labs and what Arbitrum is. I can go as deep as you guys want me to go. And then I'll dive into a specific project called dynamic pricing, which is the formal name is multidimensional gas. And then at the end, I'll leave specific time for questions as well. Cool. So we're a startup. We're a Series B startup, and we actually have 4 kind of business lines or parts of our business. First of which is obviously Arbitrum, which is a layer 2 blockchain that I will go into in further detail in this presentation. It is currently the world's largest layer 2, which is basically a separate blockchain that uses Ethereum for security. And we have 50.1% market share today. So I've included a source there as well. Our company also developed something called Prism, which is basically a software implementation of Ethereum's consensus for core Ethereum. And so we have a 24% market share there. I think there's around 6 or 7 players in that space. And this is kind of open source technology that we contribute to. Similarly, we have a VC arm on our business side. And then obviously we acquired a company called ZeroDev late last year that is focused on smart contract wallets. So when you use the blockchain, you need a wallet. And so we build and ship a version of that as a SaaS product for our customers. So this is a very basic slide about what Arbitrum is. Arbitrum is a blockchain. And in this diagram, users like you and I trade something, send some money to each other. All of that gets recorded on the blockchain, and a resulting state gets produced. So maybe I had $1. After I sent the $1 to someone else, I'll have $0. So the $0 balance is my resulting state. What Arbitrum does is we post everything, not only just the data, but like the end result to Ethereum, which is a very famous and very censorship resistant blockchain. And by doing so, we're basically saying, hey, what the Arbitrum chain has done, you can verify, and you could go and redo the math and check the results to see if they match. And that's what this green part of the diagram is about. People can validate that Arbitrum did the correct thing, and they're using Ethereum to do so. They will check Ethereum as like a trustless source of truth, and they can say that actually, yes, Derek did send $1, and Derek's end balance was indeed $0. So that's kind of how Arbitrum works. The beauty of this is that by having a separate blockchain, you have a different execution environment that can go much faster. You can charge users much less money. And in theory, both of these chains are compatible. So something you can do on Ethereum, you can also do on Arbitrum and vice versa. And so you get the benefit of Ethereum, but then also all the benefits of being a faster execution environment. So this is a really dumbed down explanation of what Arbitrum is, and we call these types of blockchains like layer 2s. They sit on top of a different layer 1 blockchain. Awesome. And so here's some stats. On the left-hand side, it just kind of goes to show that Arbitrum 1 is the largest rollup in the world compared to all other 22 rollups. The total value that our blockchain secures is greater than or equal to the sum of all of the other rollups. On the right-hand side, I have a few examples of some apps. So these are like applications on the blockchain that you can use today. but then also some institutions that have used the blockchain for their use cases. Predominantly, as you can tell, this is very financial related. And so there are futures trading apps there where you can buy and sell gold from anywhere in the world without any sort of collateral. You can kind of just like access this financial instrument. You can lend and borrow peer-to-peer. So that's what the lower left-hand side of this Venn diagram shows. And then obviously teams like Franklin Templeton, Robinhood, and BlackRock are choosing to use Arbitrum to distribute their financial products. So yeah. One last slide on stats. There's about $8 billion US worth of stablecoins on Arbitrum One. We are clearly the pack leader here. And then also we have the most diverse number of real world assets. So these are tokenized stocks, tokenized money market funds, tokenized dollars or euros or Japanese yen. These are all on Arbitrum and obviously on other chains as well, but we have the most diverse set. Cool, so that's an overview of Arbitrum. I'm actually going to pause here. Is there any questions about what Arbitrum is or Offchain Labs before I dive into an engineering project? All right, sweet. Cool, so what I'll go through is this project that we had that was meant to build a better formula for how blockchains price transactions. And every blockchain does this differently, so Arbitrum took a certain approach. I'm going to go through what we've shipped and then what's coming next. So on previous slides, I've showed that there's a lot of demand and usage and money on Arbitrum, so that means there's a lot of usage. When demand on a blockchain goes up, so do prices, because all of us users want to access the same block space. We all want to do the same thing for a limited set of resources. And so this chart shows some of the gas price spikes that have occurred in the past. These are denominated in Gwei, so you can Google or ChatGPT what that means when you convert that to dollars or euros. But my point on this slide is that on many networks, over time, when times get busy, prices go up. And so it's not as flat or stable as one might have hoped or expected. And so these are a few cases where demand was really high and gas prices followed. And sorry, dumb explanation, but like gas is what we call the fee that you pay to do something on the blockchain. And so these gas spikes or these like price fluctuations are very painful for users. So on the left-hand side, we see here that on October 10th of last year, it was around $11 US to send someone money. So if I'm sending you $1, it makes almost no sense for me to pay $11 in fees. Maybe if I'm sending $1 million, then it's a little different. But this is really painful because you couldn't really use the blockchain at this price. And I've also included some screenshots where some of our builders and teams have complained about this. This is obviously very valid feedback. So I'll give folks a couple seconds to read this. Awesome. So what we started to work on late last year was a change to how gas prices are calculated, basically. On the left-hand side, we had the before. So left-hand side, we had a single, what we call a target. And so if demand exceeds this target, which is 7 million, the prices will go up exponentially. And that will happen until things get so expensive that people stop using the blockchain and demand goes down. The goal on the left-hand side is that over the long run, the usage of the blockchain stays at around 7 million gas per second so that it's constant, and this pricing mechanism is used to keep that in check. On the right-hand side of this chart is an upgrade that we made to the chain on January 8th of this year, 2026. What we did was actually we added a bunch of different gas targets that measure demand over different windows before they change the price. And so this doesn't sound like very intuitive, like why this works, but the empirical results show that having these multiple targets make the price more smooth and also gives the chain better burst capacity, so it can handle spikes much better without having those painful gas price changes. And I can talk to you all day about it, but let's just go see the actual real world results. So on this chart here, we have the light blue line is what we currently would have charged or charged users today, and the black line is what we would have charged using the old formula. You can see that the black line is very volatile, is much higher, and this is painful for users because 1 second you're charged X amount, the next second you're charged Y amount. That's not predictable and not stable and not great for a user experience. So this is data, I believe, from January 31st of 2026, where we compare the before and after. You can see that there's a huge difference here. Faster recovery as well. And then we also compared it to our competitors. So on the same day, our blockchain did way more volume and demand than our competitors. And yet on the bottom graph here, the prices were way lower. So our new mechanism in production has shown that it is much more stable and lower volatility for the same and even more demand than our competitors. Here's a few more examples. The red line is the old pricing algorithm and the blue and green are the new ones. And you can notice that the spikes are much less, I guess, high, and we return to equilibrium much sooner. Even more examples. The red line here is the old pricer, the light blue line is the new one. Last example, I promise. So this one, you can see that even though we raised the minimum, the fluctuations and the stability of the blockchain pricing is much better now than before. Awesome. And then, so I showed you some graphs about what actually looks like on the blockchain, but this is also feedback from real users. This resulted in traffic on our blockchain to reach all-time highs, and then average gas prices are trending down with fewer and fewer spikes over time. On the bottom half of this slide, you can also see some testimonials and what people have told us. They said repeatedly that they haven't noticed anything, which means it's actually great because this means that the chain works smoothly behind the scenes without any noise or any fuss. Users generally were very happy with this upgrade. And awesome. So just to summarize how this compares to other chains, almost 17x less volatile than Coinbase, their blockchain. And we can handle 2.4 more times demand than Coinbase as well, their blockchain. Higher peak capacity with stable pricing allows people to build better apps and products and also gives users a better experience. Awesome. So what I alluded to earlier was actually two parts of this. So this second part is what we're building right now. So previously what we did was we took a single gas target and we divided it up into multiple gas targets. But gas is still a single dimension or it's still a scalar value. Dynamic pricing part 2 here splits a transaction into different flavors of gas. So when I send a transaction to someone, I'm actually doing some subtraction and addition, but also I'm writing something to the storage, to disk. These different types of operations consume different parts of the node. So I'll be using disk, but also the CPU, but to varying degrees. The work that we're doing right now is very methodical and complex because what we need to do was change how the node reads these transactions and then starts to break down these types of gas and start doing accounting on this gas so that my transaction did 5 of this flavor and 10 of a different flavor. And so we've broken this down already in the code and it's actually live on production. The next task is actually how to price it. So the new algorithm that we're actually going to ship very soon will mean that we're only going to charge you for what you genuinely use on the hardware side. So some benefits here include more capacity in theory, because usage is actually more in line with what the network can actually handle, and it's more fair. So you're only paying for what you genuinely use. This also means that hardware improvements translate more directly into capacity increases. So if tomorrow memory is cheaper, then we could increase the amount of gas that the network can handle for memory-related transactions. Doing this type of split also helps us identify better the bottlenecks in the system. So if you can see on the right, the left-hand side here, we can break down workloads by the type of gas that they use. Computation, history growth, so logs, the amount of data in bytes. So this is call data, storage access, storage growth, all those things allow us to really granularly analyze how the blockchain is being used, and then we can fine tune it so that fees stay stable. And just to repeat, like if I am doing something storage heavy, but you are doing something computation heavy, we will pay different prices because we're doing different things. And before on other blockchains and even our competitors, they don't do this. And so what we're making, what we're doing is we're making the blockchain smarter here with the pricing algorithm changes. And just to put it into like more concrete terms, each resource that I called out last time will have different gas targets. So like a little table for each one with storage gas, compute gas, et cetera, et cetera. And this compounds and builds upon what we've shipped in January. We expect much more stable and smooth price changes. We also expect better capacity, and obviously the pricing is much more fair. We're doing a lot of analyses today and benchmarking to calculate these values. And there's a lot of analysis that are involved there. I'm happy to dig into that if people are curious. Cool, so my presentation was very short, just 20 minutes. I will now open up for questions. I can dive into anything specific that people are curious about, or a different topic altogether. Thank you, everyone.
Thank you very much, Derek, for the great presentation. Guys, go ahead and ask questions. I have some in my mind, but let's hear the audience first. Okay, I will start first. So the way we understand the relation between Arbitrum and Ethereum is that Arbitrum has its own gas mechanism and Ethereum has its own gas mechanism. When there is congestion in Ethereum, this means that layer 2s are kind of fighting for the blob space, the way they send their data to Ethereum. And the dynamic pricing, does it take into account the congestion that might come to Ethereum, or is it entirely isolated and we talk about only Arbitrum? This wasn't kind of clear.
Yeah, that's a good catch. It doesn't take into account the L1 or the Ethereum prices yet. That's a separate project that we have on our backlog for later in the summer to improve that. But you're correct, this is separate. Every blockchain handles this differently, and so we're going to improve ours later this summer.
Okay, so to follow up a little bit on my question. So I understand now that it's separate, but as far as we understand, where this congestion in L1, the L2s are competing for space and they also increase their pricing. This dynamic pricing that you showcased, does it take into account somehow? Or if that happens aggressively, this means that Arbitrum kind of overpays for fees?
The thing that I presented today doesn't take L1 pricing into account. But you're totally right. Yeah, okay. And I was saying we're gonna make a change later this summer to fill that gap.
Great, thank you. Guys, any other questions?
I see a question in the chat. I'm happy to talk about that too. Give me one sec here. Yeah, so the 5 resources are in this slide here. I'm sorry if the chart is too small, but basically it's on the x-axis. It's going to be computation. So we basically took every transaction that you do on a blockchain. It's actually it can be broken down into really mini steps, and each of those steps costs a certain amount of gas. So what we did was we looked at all of these things these are called opcodes, and then we said, okay, which one of these is computation? Which one of these is related to history growth? So writing logs, for example, to memory. Which of these are storage access, so reading storage slots from disk, and stores growth, writing data to disk. And we also have something called L1 and L2 call data. So this is measuring the size in bytes of the transaction that you're sending, because that costs gas to facilitate as well. So those are the, let's see here, 1, 2, 3, 4, 5, 6, 7. Technically, there's around 7 resources, but as I mentioned, we won't be touching L1 call data until later this summer, that's when we start to work on improving how Arbitrum handles L1 congestion.
Okay,
So
this gives me, yeah, Yorgos, is the answer clear? Do you need any more?
Cool, I'll assume yes.
Okay, I assume yes too. Okay, now this brings me to the next question based on this. So, from what we have understood till now, somehow layer 2s were competing like to have much more transactions per second and to reduce the fees of the transactions. This, I assume, is in the direction. Oh, George came back. Okay, go ahead. The question for do the fees take into account the total need for users' resources or just each individual user's demand?
It takes into account what so the fee is actually 2 parts. How much money it costs to post the thing on Ethereum, which is what Giannis was asking. And then the second part is like the L2 fees, which is what I'm presenting to you today. So when you use the blockchain, I will quote you a price. And then when you execute your transaction, we will refund you the difference if you actually used less resources than we estimated. And we will always conservatively overestimate. Does that make sense?
To me, yes. Yorgos? Yeah. Yorgos is very happy now. Okay. So let me remember the question I had. Okay, yes. So as I mentioned before, layer 2 seems like competing in the sense that they are trying to increase the transaction per second and they're also trying to reduce the fees. If I understand this dynamic pricing mechanism, it aims to have a better user experience so that you can have more reliable fees when congestion happens. Can you share with us a little bit of the insight, like what are now layer 2, especially Arbitrum, are trying to build on? Are you trying aggressively to increase the transaction per second, which from what I understand is like in a very good level? What is the direction that we're actively getting in this ecosystem?
Yeah, I think we're always trying to make number go up. But strategically, the thing we care actually a bit more about these days is like institutional adoption. And we're seeing finance come on chain. So we need to build more features that cater to financial use cases. One feature that we're building that's public is the ability for someone with their own blockchain to sanction and filter out bad actors. And you can do this at the blockchain level. So this makes it kind of more pluggable and compatible with modern like financial regulations and compliance. Like MiCA in the EU, for example, or GDPR in Germany as well. These are also different things that we're looking at now these days. So the short answer is like, of course, we're going to try to make the blockchain faster, but faster is not the only way you gain adoption. We're also looking at like strategic features that set us apart.
And to be sure I get it right, when you're talking about bad actors, you are not referring to consensus individuals that are harmful. You are just talking about addresses that might need to have passed from a know your customer policy, right? And you would like to enforce this on chain?
Both. You can do either. You can filter only North Korea, or you can filter out KYC, like non-KYC people. It's up to you as the person that runs the chain. And so we're seeing this with teams that are like considering building their own chain. Having this feature available to them gives them those options. So you can do both.
Okay, great, thanks. And in terms of censorship, when you said like to cut down North Korea, you're referring to not giving them access like through the RPC or identifying them as individuals that they don't want to have access on the blockchain, or like having another censorship mechanism enforced on chain?
Another mechanism that's much deeper, like at the blockchain level, at how Arbitrum works, so that no one can bypass it. This way, it's like built into the chain itself.
Okay, thank you very much. Those were my questions. Guys, is there any other question here? Okay, I assume we have no more questions. In this case, we can start closing the event. I want to thank Derek for his contribution here. Jan says, thank you for your presentation. We all thank him. Guys, if you don't follow us on Instagram, or you can join us on Discord to learn about our new initiatives. We intend to have one workshop every 15 days or 7, depending on the availability of the speakers. Thank you, Derek, again.
No problem. Happy Thursday.
Happy Thursday, everyone. Happy Easter to those that celebrate. Anastasis has sent the Discord link for everyone in the chat.
Thank you so much for stopping by, Derek. Appreciate you.
Yeah, no problem. No problem.
Appreciate it, guys. Okay, see you in the next webinar. Thank you again, Derek. Bye, everyone.